Hey everyone, thanks for coming. My name's Clifford Agius. I'm a freelance .NET developer. I work mainly in mobile with Xamarin, MAUI, but also IoT. Trained engineer. I worked for a motor company in the car industry for 11, 12 years, and then moved out into the aviation sector. You'll find me, my Twitter handle is on the side of all my slides. Not that I'm desperate for you to follow me, but please do. I'm Microsoft MVP, have been for 2 years now, and hopefully a third, fingers crossed. Just means I can sort of get a little bit of insight into what's going on behind the scenes at Microsoft. And I'm here today to talk to you about how we, as .NET developers, can take our skills, our C# and F# and VB, if that's scary, and use that on tiny IoT boards like this one here, a Meadow F7 from WildernessLabs. I don't work for WildernessLabs, I just really like their tech. I followed them on Kickstarter, and if you don't like that, then you can use little boards like this, which is an ESP32 CAM. You get a pack of 3 of these off Amazon for about £18, or you could, until the world went crazy for chips. But I'm going to talk to you about how we can take our .NET skills, stick it on to write a bit of code and run it on a tiny microprocessor. But I know what you're thinking. Some of you in here probably is like, IoT, I've heard of it, but what really is it? So let's talk about what it is. And why do we need to bother? .NET developers, we're used to writing things that run on the front end, the back end with Blazor and all this sort of thing. ASP.NET pages. We work, for the web or a back end line of business application. We never really think about taking our skills and putting them down to small little boards. I've got some of these boards, ESP and the Meadow boards, running off battery, sitting in the field and collecting sensor data and sending it to the cloud once a day. And they've been out there for months now, and every couple of weeks, tech goes out there and changes the battery. That's the sort of thing we can do. Maybe you want to sort of have that button for a big build button, flashes and stuff like that when the build runs, or you want a big red light when the build fails, that sort of thing. A bit of fun in your office. Maybe you want to control your home, the stuff around your home with your HomeKit, etc. Or you just want that blinky lights because you're an awesome Twitch streamer and you want to, make it all a bit fancy behind you. But this graph should be enough to entice you to come across and play with IoT. We'll go back one, shall we? There we go. 2022, 11.5 billion, that's with a B, billion IoT devices connected to the internet on a daily basis. That's a lot of devices. There's 7 billion people on the planet, so that's one and a bit each. Considering that's from babies to seniors that have never heard of the internet, that's quite impressive. This graph was one that I thought was a bit more realistic. It's from Statista. But you look at some of the others, and it's a logarithmic graph. It just goes off the chart pretty darn quick. So you think in 2024, there'll be 2 devices for every person on the planet. You could run .NET on all those devices. But we've all heard of it, and we all know about it. Internet of shit. My clicker stopped working. Oh, no. Well, there you go. That just proves the point, doesn't it? I said it once, and there it is. Oh, well, we're back to the space bar, I suppose. This one, if you're on Twitter, just for daily giggles, follow Internet of Shit. And I would guarantee it'll put a smile on your face over your coffee and cornflakes in the morning. But this is the app that goes along with a tumble dryer. And I just love, see what you're missing in the middle there. That just cracks me up. It's, learn about more. These were all in the last week. I've grabbed these this morning just because I think they're so funny. This one had me falling on the floor. We laughed earlier. You want to connect the toilet to Microsoft Azure IoT Central. But the bit that gets me is only data that is logged, don't know what they're logging, at time of activation. And then they put in brackets, what are you doing? Come on, you're ruining my talk. At the bottom there, if you hear a saber ignition, is that like a light sound? I don't know, upon locking the door, your visit will be logged. I mean, what are they doing with this? Wouldn't they want to know the fact you've just gone to the toilet? Sure, they can just have like a little counter that counts as you go in the bathroom. Not the fact you've been to the toilet and what you've done. I mean, come on. This one, right, I apologise for this. I really don't touch. This one had me giggling as well. It's a lift. It's only up and down, so it's not like you collect a floor. They could have done a light sensor to trigger lift going up and down. But no, you've got to download an app, install the app, probably log on, give them your Facebook and Google credentials and everything else, and then they'll let you move the lift without touching the button. Or you could just push the button, with your elbow, that'll work. Maybe put a bottle of sanitizer lotion next to it. That's a low-tech option, isn't it? But no, someone's gone to the trouble, spent a lot of money. I'd love to know which airport it is as well, because I've just spotted its airport authority at the bottom as well. That's going to have me afterwards now, looking what airport that is. As I say, I downloaded these earlier. And then you get things like this, where you've got a screen displaying all the data, and the workers have decided, well, we've sold out of whatever that is. It's got cellular and remain in it, and they've just put sold out across the screen. You know, it's things like that that give IoT a bad name, and everyone just giggles and laughs about it, as you'll have, and as I do daily. But we want to use it seriously for serious products. So because you might not know anything about it, does anyone play with IoT? Is anyone in the IoT space? You got John with his drums. Yeah, there's a few hands up there. Anyone else even thought about dabbling, or are you just here to learn? Yeah, okay, it's an expensive hobby. You will just buy the world and think, I need that as well. Good luck finding stuff with chips in them. But let's talk about the heart, the brain of our microcontrollers, our IoT devices, you know, whatever ones I've got here and the boxes of them I've got at home. A microcontroller is just like your PC. You've got your central processing unit. You typically don't have a GPU because there's no screen. You can run things like an E83 or a little LCD screen, but it's not GPU driven, it's CPU driven. Has a bit of RAM in there. Typically it's flash RAM, so you can burn the program to it and reburn it again. Then you have I/O peripherals. So on your PC you wouldn't have these, but on IoT devices you have GPIO, general purpose input output, and that's so you can take sensor data in, or you can light an LED because you're doing your Twitch streaming, or you can control a servo like we've got here, and we're hopefully going to get the robot to move later. So you've got all that kind of real-world connection, where your PC tend not to have that. If you want to connect a servo or a sensor to your PC, you're going to be sitting there scratching your head. It's like, how am I going to get this data into my PC? It's got to be, you know, dare I say, RS-232 or something like that you're going to need to use. Who remembers using that? Oh, yeah, showing your age, don't we? It's, yeah. But it's only got a small amount of RAM, and it's really minuscule and minute. I mean, you can get down to small balls like these, Arduinos and the likes as well. But back in the day, and by back in the day, I say 20 years ago, this is what I was playing with when I was doing electronics in the car industry. We have the PIC 1600 series, or the Atmel AVR. Now I'm showing you this because I want to show you the pain that us that have been doing it for a while have gone through to get to .NET land, which is awesome. But you can see here, it's all written in C. And you can see there at the top, you've got DDRA, which is Data Direction Register A, Data Direction Register B. We set one of them to, if I move my mouse over, if it's going to work. There we go. So we can set the Data Direction Register there, and we can set Data Direction Register there. So we can set it to output and inputs, and then we set the port B. We turn all the LEDs on, because we want to control the whole port. And then we just got a while one loop, pin A, if it's on, which is the switches, because port A was set to inputs. Then we turn on the respective output LED on as well. So that is kind of the C that is used to control on one of those chips. Looks fairly simple, doesn't it? Yeah, we can all program that. We can make that work. We can remember C from college, can't we? And make that work. But it's not brilliant. And now my clicker's not clicking now. And then in 2005, just outside Milan in Italy, a college there put together some of those chips and built dev boards around them. And they called it the Arduino. We've all heard of Arduino. And they built boards like these, Arduino Uno, and I've got tons of them at home, and I use them in projects I do with the school, etc., to get the kids excited about coding. And they've got a platform behind it, and they took the Arduino language, is a derivation of C, where they've taken C and they've put wrappers around it to make it a little bit more friendly for those that want to learn. The idea is it's a learning platform. 2005 also, Lady Ada, MIT engineer, graduate, put together a company called Adafruit, and she builds boards with her company just outside New York. And they've got the Feather form factor, which is a small form factor board, exactly the same form factor as the Meadow we've got here. And you can see all the different types of Feather there. You've got ones that have got Bluetooth, Wi-Fi, they've got network capabilities, they've got SD cards for logging, they've got LoRaWAN for connecting over radio frequencies. There's all sorts, GPS on board. You buy the board you want, and all around $20 to $30. So not expensive boards as well. Run with a LiPo battery, so just a little dinky battery like this, just the same sort of thing that's in your mobile phone. Plugs in and it will run for a couple of weeks off a battery. Put a solar cell in there as well, and you're good to go for months. The one on the right, Paul Stockingham and his wife, I can remember her name, begins with R, hence the Paul and P and R in the initials of the thing. They've got the Tinsy boards, same form factor as Adafruit, which means all the boards, all the hats that you can put on top for doing things like servo driving or doing extra logging, sensor boards, etc. Will all fit exactly the same pin out, voltage points, etc. all in the same place. But these have got, the top one there, the new one that just come out, the 4.1, has got 600 megahertz processor. I mean, that's like, desktop PC a few years ago, wasn't it? It's not that long ago that we all had our kind of Pentium Pros running those sorts of speeds. But it's now on a chip that sits on the board that's that big and runs off a battery. This is the sort of stuff that's, running our mobile phone. But again, like I say, Arduino, they've got their own language. They've taken what we had earlier that was directly to the chip and was compiled down to the chip. And now we've got set up, we set the pin mode of pin 13 to outputs, and then we digital write pin 13 to high to turn the LED on. We'll delay, which is our thread.sleep, for 1,000 milliseconds, and then pin 13 to low will turn the LED off again. And we wait, and we just loop around. We just sit there doing that all day, every day, until the battery goes flat. Which is kind of cool. Again, we can write that. It's a little bit easier to understand than earlier, which is the whole point. We might download the Arduino Ide, which looks like this. And I'll be kind if I'm saying it's Notepad+. It's not even ++. Has anyone used it? We've got a couple of hands, haven't we? It's painful, isn't it? There's no code completion. You haven't got Copilot doing that tab thing for you. Yeah, it doesn't even give you suggestions or hints. If you write the wrong code, it will happily compile it for you. Yeah, it's a horrendous IDE, but it does what it needs to do, which is for kids, so they can't kind of break the world. We zoom in though. This code here is similar to what the one earlier did, and I've lost my mouse pointer. There it is. So we've got a Neopixel there. So a Neopixel is an LED that's got 3 colours in it, RGB. And so we set up a Neopixel, we set up the delay time, and then we've got a bit of code, because if you run it on an AVR 80 mega, a tiny 85 chipset, then you need to change some of the clock frequencies. And then we just set up the Neopixel, we run through the colours and over the time delay. That's in C. Now you see we went from pin 13, turn it on, turn it off, to running an LED that's got 3 colours in it, so essentially 3 LEDs on our board, and we're suddenly into code that's like, oh my God. Show that to someone who's learning Arduino code and C, and they're going to be like, I don't know what's going on here. But the IDE doesn't help either, because it's not helping your code completion, etc. So if you are going to do Arduino, I highly recommend it. It's a great place to learn IoT. Awesome, awesome, awesome plugin you can buy for Visual Studio called Visual Micro. That allows you to use all the Arduino stuff, exactly the same as the Arduino IDE, but you're inside Visual Studio, so all your key bindings work. It even gives you a bit of IntelliSense. And the awesome thing is you get your F9 debugging back, which you can't do in Arduino land. But what it does is when you put a breakpoint in, it inserts a little bit of code, snippet into your code there. So you have to recompile and send it back to the board again. And then when it does, it hits that code, it sits in the while loop, waiting for you to click enter, and it has to be the enter key. And then it runs on from that code. But while you're stuck there, you can look at the registers, and you can put little commands in to send it out to the debug console, write line.print and stuff like that. But awesome, awesome plugin as well. Of course, you can use Visual VS Code if you're a VS Code fan. I use that as well on some of our projects, certainly in schools, because they obviously can't install this on their school computers because they're not allowed. Boo. But we use VS Code as well. But we are .NET developers. We want to play in C# land, yeah, or S# if you're that way inclined, or if you want to play with VB, you crazy person. So we want to work in that world. This guy stood up at a conference a little while ago and said, .NET runs everywhere, from the clouds to your Xbox, to your PC, yeah, even on IoT. And we're going to show how you can do that today. You can go and get a Raspberry Pi, good luck if you can find one. You can buy one of those, Raspberry Pi 4, should be $35, £35, because that is what Raspberry Pi said they're going to cost forever and more. And every time they release a new one, it's because the main chipset has been upgraded and they've got a new chip on that's faster, quicker, et cetera, et cetera. But they keep the cost the same. Made in England as well, which is awesome. But that is a full Linux machine. If you want to run .NET on it, you can install .NET, SDKs, et cetera, et cetera. A good friend of mine Pete Gallagher, you'll find him downstairs on one of the stands, Octopus Deploy stands. He's written a single line install script, which will install .NET 6 for you. You just go out to his GitHubs there and download it and install it, and it'll do it all for you. But if we look at this, a Raspberry Pi it wants a 3 amp power supply for Raspberry Pi 4. Its average consumption is 600 milliamps. You're not going to run that off a battery. Well, if you do, it's going to be a really big battery for a really short period of time, which is not what we want. So you can do that if you've got power nearby. That's good. And I run projects for these. A client a little while ago needed 20 Raspberry Pis. We couldn't find them. We got 8 in the end. And then the price was instantly above £100 on eBay and Amazon because all the scalpers are out there trying to sell them to you. But if we look at the C# code for this, this is just a console app that we're running. And we set the pin, set a light time, and then we got a while loop that goes over and does exactly the same as the Arduino code. But because it's in C#, I'm betting you look at this and think to yourself, I could do that. The Arduino one, you say, yeah, I'm uncomfortable, but I could do it. But instantly, it's in C#, you got your curly braces and everything else, and you're like, yeah, I'm happy. I can do that. I can make that work. So we moved that over and just show the Arduino code behind it. It's a little bit more verbose in C#, a little bit more brackets, etc. But it's much the same as well. But we want to run it on one of these little boards we've got here. So if we want to run it on a microcontroller, we've got 2 options at the moment. We can use the WildernessLabs boards, made out in the US. I said made in China, but sold from the US. So you can go out to the WildernessLabs website and buy one there. Again, I don't work for WildernessLabs. I just like the kit. An interesting story, you see this lump of wood? You get one of these with your board. Yeah, it's not a coffee mat, as I was using it for the first couple of months. I had the board. And then I spotted on one of their tutorials, they had the board stuck to it and the breadboard stuck to it. I was like, that's what that's for. It's not a coffee mat. But yeah. So we've got WildernessLabs. That runs, as we'll come to in a little while, that runs .NET, and it's got the .NET Mono runtime on there, as well as some other bits and bobs. We'll talk about it in a minute. The Nano framework is a framework which runs on ESP32s, so like these, STM chips, Raspberry Pi Pico, a little £4 board you can get as well. That there is Dotnet Foundation project, and it's completely open source, all community driven. And with that, what they've done is they've taken the C libraries and they've put .NET wrappers around them. So it's all interop, etc., which is awesome because it means it runs on boards like this. We've got no memory on them at all, way less than this. It runs on really, really small, low power boards that will sit in the field for months on batteries half this size, down to coin cell batteries, which is fantastic. And because it's open source, you can go in there and do what you want. I'm currently writing the library for the camera because I want to use the camera on these boards. But it's all open source, all out there. You can download it as well. The downside is it's C# as you code it, but it's not got everything. Things like generics don't exist in Nano Framework. They're coming, they'll get there eventually, but because it's open source and everyone's having to build it, they're having to rewrite generics, which is a massive package. You don't realise how big it is when you download it onto your monster laptop and PC. But when you're sticking it onto a board that's only got 128 kilobytes of RAM, you're suddenly trying to work out where you're going to stick these bits in memory. So yeah, it's an awesome project. Highly recommend it. But yeah, let's talk about the WildernessLabs. So this here is the board. It's a little bit closer. You can see it down here, and you can see it's the same form factor as a Feather, so all the hats still fit as well. They've got the compute module as well, which is the one on the right there, which is once you've developed, because it's a development board, once you've developed your project, you can use the boards by all means, or you can put the compute module into your project and solder it in. And then you get things like an SD card and full Ethernet networking, etc., etc. So really, really powerful system you can use. I'll chuck this slide up just to show the difference between the Arduino and the Raspberry Pi and the features it's got. I'd argue that Arduino's got some of the bits. Over-the-air updates is apparently coming to some of the boards, certainly the pro-level boards that Arduino's got as well. The battery charging unit is now kind of standard on most of the Arduino boards as well, certainly the small form factor ones anyway. Looking at the actual boards, and we can see that on the board we've got 2 chips. We've got the STM32F7, F7 hence the name, Meadow F7. We've also got an ESP32 at the top. Now, the ESP is doing your Wi-Fi and Bluetooth stack, as well as controlling all the peripherals on the board. So that's managing the board for you. And the STM32 is where your code, because you're going to go and buy one of these, I know you are, where your code's going to run. It's going to sit on there and run on that chip. If you need to do over-the-air updates, it will get pushed out to the ESP32. ESP32 will then write it to the memory of the STM32. And that's how they're going to do the over-the-air updates, which are coming soon. They're getting very close. Beta 6.3 dropped last week. 6.4 should drop in the next week or so. We're getting really close to an RC for the Meadow boards as well. But let's talk about the stack. The stack that sits in there, we all love a stack, don't we? We got the micro RTOS. RTOS, if you've never heard of the phrase before, real-time operating system. This is the low level. This is the stuff that's like doing the timing of the chip, all the crystal stuff, etc., etc. On the ESP32, it's the free RTOS, so open source. You can go and play with it as much as you like. And on the STM, which is the main chip, the bit we're going to use, it's the NUTX RTOS. Not that matters. You don't need to know about that. I just thought it's a fun fact for me as a geek. I like that sort of stuff. Sitting on top of that is Miguel Diacaza's little project with Mono runtime. And you'll notice, if you look at the people who are involved in the Wilderness project, they all worked at Xamarin before. So all from the mobile worlds, and hence they're Mono experts, and they've written the runtime that runs on that RTOS, which is pretty darn impressive when you look at the amount of memory footprint they've got. Sitting on top of that, we've got .NET Standard 2.0, about to be upgraded to 2.1. They're currently on .NET 5 SDK. They're about to move to .NET 6. There's some stuff behind the scenes to do with the chips that they're struggling with. But I spoke to Brian literally a few days ago, and he says it's coming. It'll be there shortly. I was hoping I could announce today, but sorry, I can't. Top of that, we've got security. There's a crypto chip on board as well, which allows them to control the security. So when you do connect to the cloud, you can get a secure key, etc. So that sits on top of that. And that is, the Meadow OS is locked down. That's run and owned by WildernessLabs. So that's their bit. I think above that, yeah, is pretty much open source. So we've got Meadow Core, which is all your general purpose input output, does your Bluetooth, does your Wi-Fi, does all the bits and bobs that you want to work, that you're going to use. And above that, because memory footprint is really, really important, and you want to keep the memory usage down, then you've got all your foundation stuff, which is all the peripherals. So if you want to drive a survey, you want to talk to a TFT display, you want to talk to an atmospheric sensor, heaven forbid you want to do temperature and pressure, because that's what all IoT projects do. But you download them as NuGets. So you go into Visual Studio, go into the NuGet library, type Meadow, and then what you want afterwards, and there should be one there. There's hundreds. There's not one there. The team are quite open on their Slack channel. You can go out to them on Slack and just say, look, I'm looking for this sensor. And they will, I've seen them knock one up for people. Certainly if it's a fairly simple sensor, they will write a library. If you look at IoT projects, and this is a bugbear, it's Pete here. Yeah, he's at the front. He knows what I'm talking about this. He's the one that wrote the Raspberry Pi project. If you look at any IoT projects on the internet, yeah, or you go and watch them on YouTube and stuff, they all do temperature and pressure. And it's an absolute bugbear of mine, because you plug it in, you write your code, you read the temperature of your room that you're sitting in when you're writing your code, and that's it. Because the temperature isn't going to change much, is it? You can sit there and breathe on the sensor, you can put your cup on it to make it a bit warmer, and it goes up a bit. It's really, really boring. You try and do IoT stuff with school kids, and you show them this, and they're bored instantly. You flash a light and move a robot, and they're like, wow, that's awesome. So we're not going to do temperature and pressure because it's boring. So we're going to cross that off, and Pete knows why. We're going to jump into some code. So at the moment, I've got, in fact, actually, I can come out of this. I've got, you should see my camera pop up. I've got a Meadow F7 sitting down here. You can see it's got a light that's blinking away. I've got a breadboard, which is one of these. If you don't know how these work, you've just got strips going across, so the pins horizontally are connected, except across that breakpoint in the middle, so you can put a chip either side of it. And then down the outside, you've got power rails. To drive the power, because the robot needs a bit more power, I've just got a power board here, which just takes power in from a USB or from a power brick, converts it down to 5 volts or 3.3 volts. And I've got 2 rails running along the side there. So that's what's powering that, because you can drive a servo from your output of your Meadow board probably 2 or 3 times, and then you're going to burn the thing out. It's not designed for driving high current devices. Turn on LED, 20 milliamps there or thereabouts. is probably good enough, but much more than that, you're going to burn out the drivers. So just a word of warning, because those that start on IoT think, yeah, brilliant, I'll drive this, and it kills the board instantly, and you're on Amazon and eBay and ordering a new one. But yeah, these little things, I think I got a pack of like 10 from eBay for like 10 quid. How they can make them and ship them from the other side of the world and deliver them to my door from Amazon for that price, I'd love to know. But yeah, there you go. So we are going to, where's my mouse pointer? I'll tell you what we'll do is we'll duplicate. There we go. So we'll do that. That way I can stand here and not walk over there. This is a cool plane, by the way. I'm building one of these, or trying to, slowly. We are going to go out to the CLI. And if you go to the Meadow website, WildernessLabs website, you can download their CLI tools, which is how it's all done at the moment. They are building a fully featured Visual Studio plugin, but they've concentrated on getting the board ready, and then the plugin comes later. But it's all via, and it means they can iterate quicker on the CLI. But if we type Meadow H, we'll get our list of commands that we can run. So we can download the OS, and they've put them in the sort of order that you're going to kind of use them. So download the OS, we'll download the latest bits from their GitHub and put it onto your machine. Yeah, in a folder where they know where it is on your machine. It sticks it there for you. I'm not going to do it because conference Wi-Fi and the likes. Install the DFU, it's device firmware update utility. It's going to install that for you as well. And again, you just write the commands, go and grab a coffee, come back 2-3 minutes later, and you're good to go. And then you can listen to ports, yeah, because you want to know what port your board is plugged into. So if you look at the no, it's gone. It's sunk down a bit in your device manager. You'll see in your COM ports, you'll see the serial port is down there. And that's, so I'm on COM7 with this board. You'll find after a while of playing with lots of different boards that you run out your COM port, you're up COM port like 30 something. And then there's a little script that I found on the internet somewhere that I just run that and it deletes all the history of the COM ports. So you find you need to use that. So you do that, you can flash, you can turn off the Meadow, you can update them, the Mono, you can disable the Mono, which you need to do when you're doing updates, otherwise your code is still running. You try and update over the top and you tend to break things. So it's recommended now, you disable Mono, stop your code running, do the update of your code and then restart the Mono runtime. You can do things like file list, etc. And run it all there. So if we go out and we start a new instance of Visual Studio. If anyone does conference speaking, there's a Mads Christensen who writes all the Visual Studio plugins. He's created a package called Tweaks, which adds presentation mode and lots of other things to Visual Studio, which means you can set up this, and this isn't, I don't normally have light mode and big fonts. I'm not blind, I promise. So you can just set it up and then presentation mode just opens it in this mode. So we go down, we've got Meadow application or a Meadow library if you want to write a library for your new temperature pressure sensor. Basic application, i.e. there's nothing in it, but the Meadow application's got a bit of a start project in there. You can see they've all got C#, you got them in Visual Basic as well if you want to play in Visual Basic world, or you got them in F#. So you got, because it's .NET and it's compiled, they don't care which version of .NET. If Microsoft to bring out, you know, J# next week, it would work as long as it's part of the .NET SDK. So we'll start with one of these and we will go out and we'll just call it that, application 4. And we'll let it build. So, come on, you can do it. My little surface is struggling. So out here, in our Solution Explorer, if we go into dependencies, in the frameworks, .NET Standard. That's it. Nothing else needed there. So we go into that, we've got all our normal system libraries that we're used to, we know and love in .NET world. That's the power of Mono. How cool is that? And then in the packages library, we've got Meadow, and in the Meadow Foundation, they've put that in for you in the template. But it's all linked out, so if you don't use bits, it will link those out for you as well. So that's our dependencies. So we're in .NET world. If we go into program, we'll open that up. this is a normal console app. We could all write one of those, can't we? You've got your static void main, and then we take in arguments that they use this within the compiler, and then we new up a Meadow app and assign that to the app, and then we put that thread to sleep. So it doesn't close the app and thus close the program on the board. We just stick that thread to sleep. And then on the new thread is our Meadow app. And you can see here, we've pulled in the using statement. So using system.threading. We've already done that for us. You notice here, I've not got V2 boards. They only recently come out, and I've not managed to get one yet because I've not been in stock. So you need to just delete the V2 bit unless you get a new board, because you wouldn't go and buy one. The V2, leave it there, but I've got V1 board, so I need to delete that. Onboard LED is an RGB, so it's that Neopixel that we mentioned earlier. And then we initialize it and then cycle through colors because that is our constructor. Initializing the hardware, and we set up the onboard LED. This here can be a little bit confusing, but we're just basically telling them what device it is. The device is the one we're running on. We set the PWM, pulse width modulation. It's a way of modulating the voltages. For red, we set the pin that's on. We set the red one, set the green one, set the blue one. And then we set the voltages, because you can use this LED function, RGB LED, for a physical LED that's not on the board, a bit like the Neopixel we might get, like Neopixel rings we might get from like some Adafruit or Amazon or somewhere. So we set the voltage, because some of them are lower voltage, 2.4, some are higher at 5 volts. And then we just tell it whether it's what type of anode it is, and it's a common anode as well. Again, that seems a little bit electronicsy, but it's there, you know, and if you look at the samples, look at the GitHub, they're all there. So if you're a bit confused with electronics, don't be. There's actually an awesome on their website electronics tutorial. It takes you through what an anode and a cathode is, takes you through what the voltages are. So you can just go through that a couple of hours and you'll be a electronics expert. And then all we're doing is we're setting the color pulse to blue and setting the duration. And this here is just a library that we can look at, a method, sorry. It's just pulsing the color over, you know, half a second, it's going up and going back down again. And that's literally what this board is doing. You can see there, you can see this is pulsing the different colors as it cycles through that code. But if we want to run this, we could click up here. If we go into, put a breakpoint and we hit build, we'll notice here that it's starting to build and deploy the application. And you'll see it's in, disabling Mono, so it does that for you. So it's again calling back to CLI and disabling it. It's looking at what files are in the folder structure to see whether it's got the ones it needs or whether it needs to update them, so you're not loading the same ones again and again and again. And then it goes out and deploy succeeded. It's connecting Visual Studio, and it should hit our breakpoint shortly when my computer catches up. Come on. Come on. You can do it. I'm still putting the files out there, actually. It's now putting the debug files, which is why when you F5 debug, you can see here we've hit our breakpoint. So now we can go and look at things and see what's in them. It's not been set yet, so it's got a null. So we can go and set that, and we can continue on and run our code, and the LED will stop blinking. You can see it's now blinking away there. So we've got that. Now, if we was to, we could stop that code, we could rewrite the codes, and they're hoping to bring, I forgot what it's called, hot reload. There you go, our tooltip helped me. Hoping to bring hot reload to it at a later date. It's on the to-do list as well. But we can also go out and right-click deploy, because we all love right-click deploy, don't we? It's the same as right-click publish to Azure and the likes. So we all do that. That's what we do day in, day out. But that's not too difficult, is it? You know, we can do this sort of thing. We can use console.writeLine. You notice that we had there initializing hardware. We go down here, we can see we got initializing hardware just there. So we can do console.writeLine to debug our code as well and put useful hints and tips out there. That's blinking LED. That's the IoT world, like hello world. That is kind of where we're at. I'm getting buzzed at here. But that's not what we want to do. We want to move things, don't we? We want to do something that's exciting. But what we'll do is, before we do that, we'll go out here and we'll do Meadow Files list. we're connecting to COM7, reading the partition, so it's reading the flash. And come on, there we go. So if we now go into this, we can see that our app is here. And then we've got all the Meadow things, and they are sitting here. And then we've got MS Core lib there. So it's just .NET. There's nothing special. We've got all the system libraries that we've used sitting down here. We've got net standard sitting in there. You can see, because it was a debug build, we've got all the PDB files in there as well. This is .NET, as you know and love. And you know, system XML and the likes are all in there as well. So there's no reason why you as a .NET developer with C#, F# or VB couldn't go and write a program that runs on the Meadow board today. Now you could borrow that and go and write one, and you know, world's your oyster. So it's super, super powerful as to what they've done, all based on top of the Mono runtime, which, as we all know, is being kind of sucked into .NET proper. .NET 6, 7, it's going to kind of become one .NET. At least that's what all the Scots keep telling us. There's lots of them, isn't there? And that's what we're expecting to happen .NET 7 onwards, as it all come together. The .NET 6 runtime is being tested at the moment by WildernessLabs, and hopefully that'll be out shortly, and we'll be able to run .NET 6 on there as well, which is good, because one of my bits in a minute is broken because they upgraded bits of it. Microsoft upgraded bits to work with .NET 6, which broke the .NET 5 build, so I've had to kind of force around it, but we'll get to that in a little bit. So let's go out, and we want this servo one here. So what we've got here is my little 3D printed robot, and my son put this together for me, and all the files are on my GitHub. So if you want to print your own 3D robot, you can go and get the files. And what it's got is just some little SG90 servos, little 9G servos, relatively cheap. You can pick up, you know, a pack of like 3 of these for less than £10 on like some Amazon and that. Give it a pulse width modulation. Again, the voltage that changes its width, its frequency, and it moves the servo to a servo position. We've got 3 of these. There's no other bits in there, so you just need servos and 3D printed parts, no other bits and bobs, no special screws. I think it's all, you know, there. So super, super cheap to build. A great robot to take into schools and teach kids coding. I've got that wired up, and I'm pointing at it, and you can't see what I'm pointing at. I've got that wired up down here. We've got these orange wires here, which are going through to the PWM ports. And then we've got some buttons here, which are me for controlling it as well. And then we've got some plus and minus voltage legs across to drive the servos, all run from this board here, which is giving us our 5 volts to drive the servos. And then we've got some 0 volts going back to the board for the button inputs. All fairly simple. This actual project, not the robot, they're only driving 1 servo, but this actual project is up on the WildernessLabs Hackster site as well. But let's look at the code. So all I've done is it's exactly the same code. The only difference is if we go out to the NuGet packages, all I've done is installed that one there, servos. Like I said, if you type Meadow space and what you want to use, you know, temperature sensor, it will pop up with the list of temperature ones. I've installed the servo, so that's now sitting in there and I'm ready to go. I've not touched the program, left it alone because don't need to. I don't think I've ever done anything in that package, folder or file. And all the Meadow products are done, just leave it alone. It's good to go. And then out in the Meadow app, again, because I've got a V1 board, I've deleted V2 there. And then I've created 3 servos, the servos, 3 push buttons, 4 push buttons. And then in my initialize, I set the onboard color to red. I tend to do this in all my projects. And it's my way of knowing that I'm in the initialization method. So onboard LED's gone red, I'm initializing. And at the end of the initialization, I'll set it to green. So I know the board's initialized. And then later on, I'll use colors like blue and yellow and stuff like that. And here, it may look, you know, a bit wordy, but all we're doing is renewing up a new servo. We tell it which port to run on, so port 10, and we tell it what kind of servo is connected, name servos. And that is all part of the foundation core. So you put it in there. And then we tell it to rotate to its minimum angle so it goes back to its start, so the servo should all start moving. And then for the buttons, we new up a new push button. We tell it it's the device, which pin it's connected to, so D3. And they're numbered around the side. Sometimes a bit difficult to see in the magnifying glass. Or if you download the picture that I've got, and I've got it stuck on my wall so I can see which ones I want. And then we just got a normal event click handler. We've all done button.click, haven't we? You know how that works. It's not hard, is it? And again, it's just normal .NET. Set the color to green, and then I'm not going to go through all of them because they're all the same, but we just got a void message method that when the button's clicked, button's pushed, we're moving the servo, and then we rotate the servo, and we tell it which angle, we're going to go 90 degrees, and they've got helpful handlers in here. Rather than typing all the different method names and then 90 as a degree at the end, they've just got a helper, which is their units, so Meadow units, and then you put in degrees at the end. And obviously, because we all remember from maths at school that it's not just degrees, you can have gradients, minutes, seconds, radians. Yeah, if you want to get your maths hat on and do all those, good luck. I'm going to stick with degrees because I know what they mean. And then that's it, we just repeat those down there. So the other bit I forgot to mention earlier is we obviously want to install the extension. I just remembered that I should have mentioned this earlier. And installed, so you've got a Meadow extension just there. If you want to play with Nano Framework, they've got one as well. Their extension is in my mind better. It's more fully featured. This one is still being built up by the team. You install that, and then that gives you this Meadow devices. On their website, it says that you go to View and Other Windows. You won't find it there. It's in Toolbars now. They moved it and didn't tell anyone. They moved it recently, and I'm like, where's it gone? But it's Meadow device list, and then you'll find that it will find all your COM ports there. When you're plugged in at home on your desktop port, you'll find lots of COM ports, so make sure you select the one that you've looked at in your device manager. You're not trying to control a coffee machine. And that is it. So now we can click Meadow Servo. We can F5 it, or we could go right-click deploy, which is deploy it with that, or the debugging, it deploys it a lot quicker. But we want to look at things. So it's going out, it's checking whether that is the same file that's on there. It should be quick, because it should be the same or similar code. I know it's actually sticking it on there first. You can see it downloaded it all and connected up. So it's deployed the code, which is quite quick. And we should, output window is there. So now it's just doing the connection of Visual Studio, which is for debugging, in case we want to debug into it as well. You can see it's putting all the DLLs on there. The servo core DLL, which is the foundation package we downloaded. Initializing the file system, initializing the hardware. Remember that was a console write line. I'm not sure if you heard that, but that was the servo's moving. And now, if I go for those at home that are watching, you're going to want to watch this because you might not see. If I do this, and that's better than temperature and pressure, isn't it? I mean, I'm moving something, aren't I? You know, it's 3D printed, probably cost me about £15 to make this little robot, and the kids love it. So, you know, we've got there a nice little servo package that's running and moving. And for some reason, the other buttons aren't doing anything, and I don't know why. They were working it. Oh, no. Thanks for coming along, and hello. You can see there also at the bottom on the standout button push, moving servo, and it's saying where it's moving it from and to, start and end. So you can see there, we're moving stuff. Now imagine going into a school classroom and showing your .NET skills to the kids in the classroom. They're going to be like, this is awesome. I love doing that kind of thing. It's a great demo for them. But it shows to you that you don't just need a temperature sensor and pressure sensor that you've bought off the internet, because that's what all the demos show. And the reason they show that is because a BME 280 sensor costs pennies, and they're easy to get and easy to use, and it's a great intro after you've done the flashing LED to read the temperature in your room, which I find boring. Whereas you can build this and have a bit of fun with a robot, moving stuff around. My kids, 12 and 15, the two younger ones, the old ones, a bit bigger, they've written C#.NET code for projects, and they've had this and programmed it to literally, we've screwed this down to a board and picking up sugar cubes, because there's another server on the top, picking up sugar cubes and moving the sugar cube. And they've written that all in .NET at 12 and 15. How cool is that? Yeah, so we've got the skills to write .NET, but I know what you're thinking. You're thinking, Cliff, that's awesome. We've moved the servo, we've flashed an LED. We could read the temperature and pressure, because really we want to read that, don't we? Yawn. But the I in IoT stands for internet. We've not connected to the internet, have we? let's do that. Let's connect to the internet. Well, I'm going to unplug this one. Take the electricity away so I don't get any smoke leaking out later. I say that because it's the second board I've done this demo on. And we'll plug this board in. And while that's just sorting itself out, we'll stop this because now it's really going to confuse Visual Studio. Close that one down, and we want this one here. So what we've got here is a project that's going to connect to the internet via my phone because I don't trust the conference Wi-Fi. It's going to connect to the internet, and it's going to speak to Azure IoT Hub. So, does anyone play with Azure IoT Hub? Yeah, a couple of hands going up. And what that's going to do is now we can send our data and we can stream millions of messages a second. And IoT Hub, which has got Event Hub behind it, is going to take care of it for you. Yeah, it's going to ingest all those messages, stick them where you tell it to stick them, and be that into time series insights, into blob storage, Cosmos DB, wherever you want to stick your messages, stick them all in there, and then you can lazy view them later. You can write a bit of back-end code that looks over that data and takes your trend analysis and things out of it, whatever you want to be. If you look on the internet, the projects that the Azure IoT team will show you, it will be temperature and pressure monitoring of sensors inside an office building where they're looking at an office building and they've got movement sensors. And if the temperature's hot and there's people in the room, they turn the AC on. Temperature's cold and there's people in the room, they turn the heating on. They'll turn the lights off, etc. Because there's no one in the room, so why have the lights on? Cool ideas, cool projects, and then they've got digital twins that sits on top of that and manages the building, etc., etc. But we just want to take sensor data and send it up to the cloud. Now, I said I don't like temperature and pressure, so we're not going to do that because I can't stand temperature and pressure. Anyone that knows me knows I'm a fan of aviation and love doing things with planes and flying around the world. So in the aviation world, we like doing things with GPS data and doing coordinates, so bearings and headings and distance. So what we're going to do is have a mock destination, which is here, NDC London, and then every time we update it, it randomly grabs a distance and a heading and just goes off in that distance as a vector, and then randomly goes off in a different distance in a vector. And we can feed that. This project was done for on the ESP32. It's one of these, exactly the same code base, almost cut and paste across. Again, because it's .NET and C#, it just works. And we did this for Flight into IoT. You can find it on YouTube's, on the Microsoft YouTube's. We did a Flight into IoT where we went from writing the code to running on this, to connect to IoT Hub via time series insights, and eventually out to I forgot what it's called now. It's going to bug me. Basically a big board that showed a map and the speed and height and everything else. And it was a real flight of a British Airways aircraft that's flying down to Budapest. And we basically streamed the whole data live, taking the data from Flight Radar 24 via an ESP32 up to cloud and via the pipeline. So it went out to this dashboard and Power BI, that's what it is. Brain will get there eventually. I'm getting old, you know. So what we're going to do is I'm going to burn this to the chip. So you notice there that the COM port is now changed to COM6 because that's what this board's on. And we're going to click to burn it out there, and we are going to hold on that line there, connecting to the Wi-Fi. So what we're going to do here is much the same before. We set up the onboard LED and turn it red because I said that's what I like to do. And then we connect to the Wi-Fi. Again, they've got device Wi-Fi adapter connect, and you put in your secrets, your Wi-Fi username and password. A little hint I found out this morning is the Wi-Fi passwords you can't leave blank if you're at a conference and it's an open Wi-Fi network. It doesn't like that. So I've logged a bug with the Wilderness team saying, well, what happens if it's an open Wi-Fi network? Obviously, they're thinking security. All Wi-Fi networks should have passwords, but this one doesn't. So hence, that's why I'm using my mobile phone. And then if it's successful and it's connected to the network, it will set keep the LED red. I'm just going to turn on my phone and turn on the hotspot. So, and we've hit that breakpoint. So again, we know we've hit a breakpoint, and then we will, what do we want to go into? We want to go down to there. So now we're going to connect to the Wi-Fi. You can see there it's connected into Cliff's Pixel 6, which is my phone, which is sitting there. And the Wi-Fi setup, when you've just rebuilt the project and loaded it onto the board, it takes about 45 seconds for it to connect. Once you've burnt it without all the debug stuff in there, it connects pretty much instantly. It's really, really quick. It's just a bit laggy at the beginning. You can see our LED is red at the moment. So you can see a little red LED. That's for you playing at home. All three of you, I think Jacob said this morning, wasn't it? So we've hit here. Now what we're doing is we're setting up the connection to our IoT hub. So we've got a hub name, a device ID, and then we set up our connection. We create a session with that IoT hub, and then we set up a sender and receiver link. The sender allows you to send device to cloud messages. Receiver takes a message from the cloud and receives it on device. You might remember a little while ago I mentioned the fact that between .NET 5 and .NET 6 this got broken. And so what we had to do, just to show that it works, is this little bit of code here we're repeating. We are recreating the connection again and again and again as we go around the loop 10 times to send 10 messages. And just recreating the connection because the connection hangs, so we just have to recreate it again. And then we set the LED color to blue, and then we write out latitude and longitude. We all know what they are, points on the Earth. And then we send that up to sender.send, send that message up to IoT Hub, and it writes out to the console write line that we sent a latitude and longitude. And then we close the connection, and then we recreate a new connection as well. This is outside the loop, because if you put it inside the loop, it closes the connection, and then you can't open a new connection. So what we're doing is opening 10 connections next to each other. You can't open more than 10 because it runs out of memory. So we open 10 AQTP messages, and we send them, open the connection, send the data, and the connection hangs, and then the board crashes afterwards. It's a known problem. It only became known about a week ago, and which broke my code, but this is a workaround and fix just so I can show you lovely people that it all works. So what I'm going to do is I'm going to open up IoT Preview. This here is Iot Explorer. It's still in preview. It's been in preview for quite a while now. I'm not sure why it's not come out of preview yet. But you can connect it to your IoT hub. You can see here I've got Meadow F7. I've got the Nano Framework one, which is the other board. And we've got some other bits as well.
Attention please, attention please. A fire has been reported within the building.
You have to run away or not?
Immediately by the nearest exit.
Oh no! I was about to show you all the magic. It's not smoking, is it? Not me, no. Oh well. Thanks for coming. I know you're not. But if you want to, I've got all the red and yellow ones, so you can only put green ones in the box. Okay. Is it stopped? Before you'll run away and stand outside in the warmth. Just noticing the light's not flashing anymore at the back. Do we have to run away? Yeah, the man says run away. Thanks, people. Thank you.